Hello and welcome back. In 11.5 we get to play with OR and AND problems. So we're going to sort of expand on what we did in the previous section. So for this first experiment, we're going to randomly select Alpha, Bravo, or Charlie, then flip a coin. So if we did this the 11.4 way, 3 branches at first, and each of them have 2 branches off of them, heads or tails. So A then heads, A then tails, B then heads, B then tails, C heads, C tails will be our sample space. So let's look at the probability that we selected B or heads. And remember, we're using OR the same way we did early on in the semester, inclusive OR. So this is still an inclusive OR. So if it has heads or B or both, we get to keep it. So 1, 2, that had both, 3, 4. Out of, there were 3 by 2, 6 ways the experiment could end, so probability of 2/3. On a nice small problem like this where there's only 6 possible outcomes total between 2 stages, no problem. Once you start looking at thousands of different ways something can happen, you want a more sort of abstract way to do things. So some observations that we'll make on this. Probability of B, see if you can find that. Probability of heads, see if you can find that. Okay, so probability of B, 2 out of 6, or simplified to 1 out of 3. Probability of heads, we had 3 out of 6, or 1/2. Well, the probability of B or heads, if I didn't want to do the whole tree diagram thing, I could say, okay, well, what's the probability of B? And I'll go with the unreduced for the moment. 2 out of 6 plus the probability of randomly selecting heads, 3 out of 6. But that gets me 5 out of 6. That's too many. I overcounted. Notice I overcounted by exactly the 1 that they had in common. The overlap, the thing that was in both. And that's true in general. Probability of event A or B, probability of A plus probability of B minus the probability of A intersection B, the probability that we have both. So cut off the stuff we counted twice. So in cards, for example, if I want the probability that I've selected a 10 or a club, we're going to assume that we're drawing 1 card at random. So probability of selecting a 10, 4 out of 52, plus the probability of selecting a club, 13 out of 52, minus the probability that we have both a 10 and a club. There's one card that is the 10 of clubs. So 16 out of 52, those are both divisible by 4. So 4/13 is our probability. But if they ask me to, for example, find the probability that we have a heart or a diamond, well, that is 13 out of 52 plus 13 out of 52 minus nothing. No cards are in both of those categories at once. So 26/52 is just a 1/2. So I'm going to have you all try a couple experiments with rolling a die. So see if you can find the probability that you roll an even or greater than 3. Find the probability that you roll an odd or a 2. Okay, welcome back. So the first one, probability of an even or a 3. So remember, if you are to roll a die, so our experiment is we roll a die. An even or a 3. Probability of even, there are 3 even numbers on a die out of 6 numbers total. Probability that we have a number greater than 3, so that's 4, 5, or 6. 3 of those. Minus the probability that I've selected something on both categories. So a number that's both even on a die and bigger than 3. So that would be 4 and 6. 2 out of 6 were in the overlap. So 6, 5, 4, 4, 6. 2/3 probability. Probability of an odd or a 2. 3 odds out of 6 sides. 2 is just one side out of 6 sides. And they have no overlap. In this case, where they have no overlap, that's what's referred to as being mutually exclusive. Both of them cannot happen at one time. If it's a 2, it's not odd. If it's an odd, it's not a 2. If it's a heart, it's not a diamond. If it's a diamond, it's not a heart. Mutually exclusive. Impossible for both to happen at once. In our cards world, we might be looking at the probability that we have a red or a face card. Red cards, 26 out of 52. So notice, until I'm done, I don't do the reducing. Face cards, we have 3 in each suit, 4 suits, 12 of those out of 52 total. Minus the stuff that I counted twice. Red face cards. There are 3 face cards in the hearts, 3 face cards in the diamond. So 6 of those were counted as both part of the 26 and part of the 12. So we'll cut that off. So 32 out of 52. Those are both divisible by 4. So 8/13 would be our probability. So next we're going to look at, those were the or problems. We're going to look at some and problems. So our experiment, we're going to draw 2 cards. And the first time we're going to do it with replacement. So what I mean with that is I'm going to draw my card, look at it, record what it was, throw it back in the deck, shuffle the deck. I might be able to pick that same card again. So we're going to look at probably whether we select an ace and a king. So on this one, we just do a product. So there are 4 kings out of the deck of 52. I'm sorry, 4 aces. 4 aces out of the deck of 52. We shuffled, we recorded the ace, we shuffled it back into the deck. I still have 52 cards in the deck, 4 of them being kings. So that turns into a 13th by a 13th, so 1/169th. If I do this instead without replacement, an ace and a king, I still start the same way, 4 out of 52. Now I have an ace in my hand. I now have 51 cards left in the deck, 4 of which are still kings. So let's see, 1/13th by 4 51st. Be 4 out of 663. If I want the probability of king and king, again, 4 kings in the deck out of 52 cards in the deck. Now I have a king in my hand. I'm reaching back into the deck. The deck has now 51 cards total. Now I have only 3 kings because we're still working without replacement. So that'll turn into 1/13th by 1/17th. So 1 out of, that would be 221. 1/221st. Make that a little more readable. 221. So that would be our probability, again, selecting without replacement. Now, one other important idea in probability is the idea of independence. So events A and B are independent if event A does not affect event B and vice versa. So for example, when we were selecting with replacement, those were independent events. If I pulled the king out the first time and I put it back and shuffled it again, I'm just as likely to select a king the next time. But if I select without replacement, Now I have fewer kings to work with and fewer cards total to work with. That would be an example of a dependent event.